Hello folks, this is the video segment number 8 on the use of Catia's native FEA solver to solve composite problems. So let me put this thing in the slide mode. Okay. Specifically, I want to discuss the concept of the drop-off zone in a composite problem. Let's say that we have a strip, a rectangular strip like this, which is made of laminated composites, and part of that is having eight plies or 7 plies of different orientations, and the other part, the thin section, has only three plies, uh, 3 plies. In principle, you can manufacture something like this, so the thick section suddenly drops to the thin section, basically a discontinuity there. But this is a bad idea because at the seam, at the interface, right here at the interface, you may have situation with delamination, prone to delamination, among other things. So what they do instead is they gradually drop the number of plies in going from thin section to thick section or thick section to thin section, perhaps something like this. So you have the original thick section on the right side, you have the final desired thin section on the left side, and then there's a transition zone, which is also called drop-off zone, by the way. This is better for service use. Okay, I've just shown the same thing that you see on the right hand side from the side view. So we have the thick section, different orientations, perhaps even different material if necessary, and then you gradually drop and you go to the thin section, which is shown on the left side. Okay. Now I want to demonstrate this specific. This is in the context of a specific problem, which I'm going to discuss. This problem is done as an example in Ever Barbero's textbook, and he has developed a YouTube segment on that problem, but it's using abacus, okay? And so I'm going to recreate the same problem, but show you how to do everything in Catia. The problem to be discussed is a strip, as you can see, a rectangular piece of composite, laminated composite, which is 120 millimeter in the length direction and 100 millimeter in the y direction. Okay, and these are loaded uh, in the plane XY as shown with this load distribution. Okay, now ignore this thing for a minute. Ignore this comment for a minute. The material that we're going to be using is very close to the, the the general values of carbon epoxy material. So these values and the lamination sequence or the stacking sequence are shown in here. So this is the thick section, which I call zone A. The thin section on the very right hand side, which I call zone B, and this is a drop off for the drop off section or transition section, which is zone AB. The lamination, these are cross plies, in other words, 90s and zeros, and the thickness of these laminars or plies are 0.075 millimeter. Because of the nature of the orientation that you see here, and the fact that the geometry is symmetric and the load is symmetric, you don't have to model the whole thing. You can model. You need to model only half of this. Now remember, if you put stuff here, uh, which are not 90 and 0, it leads to the fact that this is not a symmetric problem, and you have to model the whole thing. In other words, 120 by 100 millimeter. But because of the nature of this orientations, there is a symmetry, and we can do it. We can do only half of. We need to do only half of this. Now, uh, the concept of a drop-off zone or transition zone, there's a rule of thumb that people use. They say that the slope, basically the height, let me put it, the difference between the height of the thick section and the thin section. So basically the height of the drop-off, okay, uh, uh, divided by the length of this transition zone should be somewhere between 1/16 and 1/20 ratio. Okay, so in this particular problem, this number 30 millimeters is based on the 1/20 rule of thumb. Now, Barbero in this segment comes up with a theoretical deflection value of 2.578. Okay, and you will see that it's going to be that, and it's going to be also uh, out of plane deflection. Okay, some in plane, some out of plane. Okay, all right. I think I've described to you the problem. For these material that you see here, uh, it's not the standard values in the in Catia's default composite library. So I have to create this material myself as a user material. And I'm going to do this thing. I did that in video 2 from scratch, but I'll show it again how to start from scratch and create a material with the given information. Okay. Okay, so at this point we're going to create the material property features of this particular problem, because you can't find it in the Abacus data in the CATIA default database. And I did this thing in videos, I believe 2 and 3. However, I'll do it once again from scratch. So the first thing that we need to do is start infrastructure, material library. So it's going to create a new one for you. Already, although I already created one of my own, and I could have put the properties of this particular problem in that catalog, but I'm going to create an entirely new family. Couple of things. First of all, the name of the family is right here. You can see that, and you can change it. So I will call this thing drop-off library, drop-off problem. Okay, say all right. Notice the name changed here. Then we're going to double click on the new material. This is completely blank now. So first of all, the feature, I will call it drop-off. Drop-off, okay? Drop-off example. All right. Now notice that when I say apply, immediately changes the name new material to drop-off example. You see right there? And then we're going to go to composites, the composites tab, and the acute thickness, basically the laminar thickness in this problem is 0.75 millimeter. Okay, see that? 0.75 millimeter, and apply. And then the unidirectional. Let's make it unidirectional. Now, by the way, if you not choose unidirectional and put this thing in, it's not going to complain, but I think it's a good idea to be as accurate as possible. Okay, so then you go analysis. It's 2D or orthotropic, and now we put in the numbers that you see in this table. Okay, so let's put it in. Longitudinal Young's modulus is 133, 860 MPa. Okay, the transverse Young's modulus is 7706. Okay, Poisson ratio is 0.301. No, sorry, 0. Yeah, 301. Correct. G12, which is the same as shear modulus in the XY plane, you're told that it's 4306 megapascal, and GXZ, which is G13, is 4306 also, 06, 06, and finally G23 is 2760, 2760. Okay, if you had any strength properties, you put it down here to predict failure and things like that, but we don't have it. So we say okay, all right. Now this thing I can save it in either on my desktop or in a folder that I recognize. That's exactly what I'm going to do. So I'm going to say, let me see, file, save management, this material, save as. On my desktop, you see, where is the desktop here? I have a folder which is called Dropoff Dropoff here. I'm going to put it in there, and I can give it a name that I want. I'll call it how about um, Dropoff example. Dropoff 3.5. Okay, so I can close this now, and if I go to my desktop and see what I've got here, not this desktop, I've got two of them here, of course. Let's see, this desktop. If you go to that folder, there is the material library that I created. Okay, in it is only one material right now. I can add stuff to it, etc. But you know, good. So we go back to Catia and start creating our model. We start with a part file, file, new, part. Okay. What do I give a name here? Drop off part. How about drop off 3.5? 5. Okay, we're going to make it. I'll go into the shape design, generative shape design. Okay, to create the geometry, I select the XY plane. I will sketch on it. Half of that part that you see here, a rectangle 120 by 120 by 50. So in the X direction, it's going to be 120 millimeter. And in the Y direction, 50 millimeter. You say okay, you exit. Oh, yeah. I completely forgot. Now, just look at this. We need three regions. We need three sections, okay? One section, zone A, is going to be 60 millimeter. The other one, the zone B is 30 millimeter, and the transition zone is 30 millimeter. So this was not right. Go back there, okay? I'm going to make this thing 60, okay? All right. So if it helps you, you can name these things so that we exit that. This sketch, I will call it, rename it, properties, I will call it AB, sketch for AB, sketch for A, right? A sketch. Trying to get organized. Okay, good. Now fill it. Where is the fill? F-I-L-L, right there. Fill. And very good. And join. Join. Let's check the direction of the joint. Flip the direction so that the direction of the surface is down. So after I mesh this thing, the direction of the normal to the shell element is going to be up. Good. Now we repeat this thing two more times. So sketch on the XY plane again, a rectangle The rectangle is going to be here, and it's going to be 30 by 50. That's going to be the transition one, or zone AB if you want. So let me see now. This point control that point. I can make it coincident. The different ways of doing this, okay? And then the width here is 30 millimeters, 30 mil. Exit. Before I move any further, I like to rename these so that they also reflect the appropriate sketch. So properties, these are all bookkeeping issues. I'll call it A. Why don't I call it A fill? Okay, apply. Okay, and join, I'm going to call it rename properties A join. These are totally unnecessary. Right? I hope you understand. This is going to be sketch for B. So properties B sketch. B sketch. Yep. Yeah. Okay. All right. Fillet. FILL. So this sketch. And okay. Join it. This fill. Join it. Okay. Let's change the name of these things to rename properties. Where is this? Properties. I'm going to call it AB. This is going to be AB zone. AB. Join 2 is going to be AB. Okay. Now double click on it. Flip the direction of the arrow so that it's consistent with the other one. Okay. Let's go and do it with the other one also. So on the XY plane once again, I will sketch another 30 by 50 rectangle. That's going to be zone B. Okay. Clean it up. So this point, control that point, we make it coincident, and dimension this to be 30 millimeters. Exit. Let me clean this up. This is going to be right click properties. I'll call it A, B. No, this is B, right? B. Very good. Fill it. Fill it. That's what I mean. Right there. I'm going to call this thing A. It's going to be B, right? And join it. And that's going to be B. Properties. B join. Okay. Very good. Flip the arrows, double click on that last join, flip the arrow, you say okay. Now they all have normal direction, positive normal direction to the join downward, so all the elements are going to point up. All right, why don't we actually save this thing? File, save management. This is a part file, save as in that folder. Yep, drop off, say okay. Now let me create my coordinate system that's going to be used for Rosette also. So where is the coordinate system? Right here. Since I'm not plotting, since I'm not getting the contours of stresses in different plies, all I need is a single Rosette aligned with the global coordinate system, because I have no intention of doing a ply by ply stress plot, at least, yeah, stress plot along the normal and transverse direction. Those were done in videos 2 through, I don't know, 4 or 5, so you can check it if you want. So the only thing is that I'm going to move the location of the default that's created here a little bit to the left. So put the cursor on origin, right click, create a point, and for Y, put down, how about minus maybe 30, 30, okay, fine. So it's going to be placed right there. By the way, although it doesn't matter in this particular problem, what I will do, I will uncheck this so that everything is measured with respect to the global coordinate system, not with respect to this, because right now this is active, okay? So when you uncheck it, this thing becomes dashed, which means that it's not active. All right, good. So save. We now go to the composite design. Start mechanical design, composite design. Now, first thing is parameters right here. See this? Parameters, the material. Now we have to go to that library that I created. So it was on my desktop. It was in this folder. There it is. This is the one that I created, and we select it, and we say OK. And then this is the library that's being loaded, and we say OK. And there's only single member in that family, and therefore it just picked it up. If there are several, it will give you the opportunity to select from each one of those materials that you have in the family. Okay. Now for direction, this particular problem is a cross-ply problem. We only have 0 and 90. So we just need 0 and 90. You don't have to delete these, but if it makes you feel better, you can delete it. It doesn't matter. We don't want to add direction. For rosette, we're going to select the one that I created. Remember that coordinate system that I created? Add a rosette, and select this, and hide this. This is the fancy rosette that they added in the last 4 or 5 years. Okay, now we're going to do it as laminate. Okay, I'm going to create 3 laminates: laminate A, laminate B, laminate AB, and later on we're going to pick those as in my zone. I can do it with laminate, or I can do it later on ply by ply. Let's do it as laminate. Okay, laminate. Okay, so add a laminate. We're gonna right. So for material, there's only one. Add. There's the material. Oops. Oh, orientation is. No, let me do it differently. Okay. Yeah, that's okay. Add. Fine. Add. Oh, sorry. uh, stacking sequence. So laminate. I'll call this thing laminate A. Okay, laminate A. Maybe I'll put the A on this side. A to be consistent with the other naming. Okay, so lime drop off example, and the first one is uh, 90 right here. See, 90, 0, 0, 90. Okay, so that's this. Add. Okay, do another one. Add another laminate. Stacking sequence, material is the same, drop off, and for orientation is going to be 0. Add. Oh, I'm sorry, this cancel. Let's go back, clean it up here. I've double clicked on this, okay? I need another one. Drop off 0. Laminates, it's going to be, stacking sequence is going to be defined here, there, okay? So another one, another 0, and 90. Add. So notice that for that laminate 90, 0, 0, 90. That's what I did. 90, 0, 0, 90. And this is it. Okay, do another one. This one is going to be transition. How about calling it AB. Okay, so stacking sequence AB. Material is the same. And let's see now. We dropped the 9 deploy on the top, so it's going to be material is drop off example. First one is going to be 90 add. Next one is going to be 0 add, and next one is going to be 0 add. Please, you have to understand that this is not the only way of doing it. There are many other ways of doing these things in Catia. So I'm trying to do one that maybe it was not done before in the other examples. Add, finally, this is going to be B. At this point, we have not created the plies. All we're doing is define laminate with the stacking sequence. Stacking sequence material is the same. This is going to be 90 and 0, right, at the end. Add. And finally, another one is going to be 0, add. So we can see that 90, 0. Say OK. And OK. Very good. Now we're going to create zones. We have 3 zones here. So where is the zone? Right there. See this? Zone group. We can go ahead and do it ply by ply manually from the beginning, but that's not what I'm doing. I'm using zone method. Zone group. Zone group, I'll call it zone A. Okay. Selection is that surface, the surface. Draping direction up, and rosette is rosette number 1. I can take care of this and then move on, or I can create the three zones and then 3 zones and then come back and do it. So let's actually do this. Let's take care of this thing first, okay? Let's take care of this thing first. Zone, that goes group A. So we can select with the contour. For the contour is that first sketch that I created right there. For the laminate, I have 3 of them, but the one that I want is A, right? A, 90, 0, 0, 90. And for the rosette, automatically is picked. All right, so laminate, that zone has been created. Let's do another zone group. This one is going to be B. Okay, surface is going to be the second one. Flip the arrow up, and for rosette 1. Okay, there is your zone B. See that? First one is zone A. This is the one that we did earlier. Oh, I wanted to change the name of this thing to this zone to A. So let me clean this up first. Let me go to that zone 1. I'll call it A. These are naming for bookkeeping purposes, okay? Right there. If you want to do that in any way you want, that's fine too. So B zone has been created, group has been created. Now we're going to create the zones in it. So this is going to be B, or I'm doing B, right? Cancel. Let me do AB first. So double click on this. Oh, AB right there. It was AB. Oh, there. This is AB. That's what I wanted. AB, right? First one is A, second one is AB, and now create our zone that goes into that zone group. So this is going to be AB. Laminate is going to be AB. Okay, rosette is already picked. We say OK. Oh yeah, the contour, I forgot to do the contour. Geometry, contour is going to be the second one, right? Cancel. Cancel, let's see. I did so many back and forth stuff here that I might have got lost. So zone group AB is right here. Let me minimize this. Zone group AB is here. Okay, let's try it. There is your zone. which is going to go into, oh yeah, not in group A. See, this is a mistake that I made. AB for curve is that contour, okay? But be careful because you're creating different groups. You have to pick the right one here. Laminate is going to be AB, and the rosette is already created. Good. There we are. So, see, the only thing is that I forgot to call this thing AB. Double click on it, just AB. Okay, so everything is done uniformly here, as you can see. Let's now do the zone group B, okay? So there is the zone group B. Surface is right here. Flip the direction. And I will check, make sure that the direction was also flipped here. I can't remember what I did in that AB one. So rosette is 1. Say OK. Okay, there's the zone group B. Let me check the direction of this. I'm going to double click on that. It was changed. Okay, good. B. We did it. Everything looks good. And now create the zones associated with this zone group. Remember, you have to select zone group B for the contour. Is that last sketch, which is called sketch B, by the way. Laminate B, and the rosette, I'm sure is right. Yep, it's okay. So we have created our zones. Okay, we have created 3 zone groups. Zone groups A, B, and B. Within each, we have created the appropriate zone. Zone A, Zone A, B, and zone. Oh, this one I forgot to name it B. Okay. You know, when you're doing a complicated problem, it's a good idea to make sure that these are all consistent, exactly the way you want it to be. Now we're going to create our plies, okay? So plies, now how do we do this thing? There is, it's not that, oh, right there. See that? Plies from zones. Plies from zones. You click on it. There's 3 groups that we have. So we want create without staggering. Remember, without staggering, right? And we're doing A first. Yep. Let's check. So here is your plies stacking. There should be four plies in it according to the laminate that we created. It should be 90, 0, 0, 90. Let's check it. There should be your 90. Oh, okay, now remember, the zone, when it creates zones or applies from zones automatically, we have to fix it. Let's go ahead and fix this. So this should be 90. This is the first one. This should be 0. I understand that in my laminate, I described them properly. But when things are done from zones automatically, then these things may change, and you have to fix it if necessary. This is 0, and this last one should be 90. Good. Oops. I think I fixed all of them. So let me minimize these and collapse that. Now go and create the second stack. So click plies from zones, zone group AB. Make sure create without any staggering. Say OK. There must be three plies in there. We're going to check the orientation, make sure it's correct. The first one should be 90. 90. The next one should be 0. I'm not sure why it changes things. 0. Last one is OK. Let's collapse the tree. Okay, so another one, plies from zones B, group AB, create plies without staggering. You know, even if this is not checked, it's going to do it for you, but it's going to give you a warning message. Let me try one here. See, it's okay. It'll do it. It's just that it gives you a warning message. Okay, this should be 9000. 90, okay, that's good. The next one should be 0. This is good. Okay, collapse. By the way, it's a good idea always to check, make sure the directions of the plies are good too. If you click on this ply, the direction should be up. Is it? Yeah, right there. You can see the arrow here. See that? Let's try another one. Let's try something from here. Ply 1, see, up. Good. If they're wrong, then you can always flip it, but that's okay. So save. We're almost finished here. Let me hide your stacking sequence. Oh, you know what? Before I do that, let's check it. Let's check something. Make sure that our ply exploder give you the correct order now. So ply exploder, first one, apply. See that? 90000. The next one should be 90. Sorry, first one is 900090. The next one is going to be 9000, 9000, and the last one is going to be 90 and 0. And if you want all of them done, oops, shift, apply, all of them are going to be at the same time. They match, cancel. If you say okay, it's going to be there. So yeah, then you have to hide it or whatever. Okay, so let me go ahead and hide my stacking sequence and hide the composite or the composite PD. Okay, so that I have only access to my surfaces, and I'm going to also hide the sketches, sketch A, sketch B, and sketch AB. Okay, good. All right, so save everything. Now we're going to go to meshing. So start mechanical analysis simulation, advanced meshing tools. We say okay, let's do this thing uh, mesh. That's going to be AB. Sorry, this is going to be A, right? Zone A, and 20 millimeter. Remember, this whole thing was 60. So let me make this thing 10. So the elements are 10 millimeter long each. Now, automatic mesh capturing, this is important. Leave it on here because along these two lines, on the two different sides, different nodes are generated because we are meshing each surface individually. Now, to make sure that they're merged together, if they are within 1 millimeter, this has to be on, okay? And of course, quad only and parabolic. Say okay, zap it, exit. Let's do the other one. So this first one, if you want, is AB. Okay, let me rename this thing. Properties. I don't need it. I'll just leave it there. I can change this thing to AB so that, also not AB, A, so that you can identify them. All right. The next one, this one, same thing, same thing. Say okay. Zap it. Okay. Exit. Next one, this is going to be region B. Same dimension. Zap it. Okay. So we have created our mesh. Now we're going to go to generative structure analysis. Okay, first of all, let's look at our mesh overall, right there. And if you look at it, so each one of these is 10. 1, 2, 3, 4, 5, 6. So this is the first line. And if you put the cursor here, number 33 is over there. And if you go to the other side, it's number 33 also. Okay. Same thing with these two. This is the other line right there. So 129 on this side, 129. If you had not used the mesh capture, automatic mesh capture, then they will have different node numbers, and watch the previous video. You see that the outcome can be disastrous because they don't talk to each other. Okay, deactivate this mesh. Let's go and import our properties. So there, imported composite properties. Support is this one, and it's by zone. Go select the zone. Go select the zone, and the zone was, now you have to go to the part here. Right there. It's a zone group 1 or zone 1. If you select zone A zone, it'll pick the entire group. Okay, you can check right there. The entire group is picked. Okay. And make sure this unsymmetrical is unchecked, because we are stacking these things exactly like it is. These are not symmetrically positioned around that surface. You don't start at the bottom and stack it up. Okay, that's why you should not say symmetric. Okay, and just so that I remember, I call this thing A. Okay, fine. The other one, this is a surface. By zone, go select AB, say OK, and I'll call this thing AB, unsymmetric, right? And last one, that surface, make sure it's unsymmetric, zone B, and I'm going to call this thing B. This is why I insist on giving these meaningful names. It's easier to debug if needed. So you can see that the properties A, B, B. I should have done the same thing for the mesh, but that's okay. Now, restraints. Okay, so for this restraints, this edge is clamped. You can see that edge is clamped, and this is a symmetry restraint. Symmetry restraint for shells is like this. So you go to user define. Let me uncheck everything. These three edges, this one and that one and that one, they all lie in the XZ plane. If they're lying in the XZ plane, they don't move in Y. So this displacements, Y is checked, means it doesn't move, and the rotations are exactly the opposite. Exactly the opposite. If this is unchecked, this one is checked. If this is unchecked, this one is checked, etc. This is how you impose symmetry restraints in beams and shells. Last thing is the load. The load, I'm going to use this line force density over here, and my problem says it's 10 what is that? 10 Newton per millimeter. So I put down 10 here, 10 Newton per millimeter. Oops. And it's going to automatically make it 10,000 Newton per meter. We say OK, save our analysis, file, save management, save as, analysis. Okay, so that's a good name in that folder. And before you run, you always pray. So let's run it. And I better get a deflection of 3, whatever theoretical deflection was. Theoretical deflection was 2.578 millimeter. Okay, say yes. Good. Let's look at the deflection. Whoa. Did not come out to be correct. Okay, the number is not correct. We've got to figure out what we did wrong, but we're going to check it. Don't worry. Okay, it's one of those unfortunate things that has happened to me in Catia when I'm using its solver. I spent a lot of time trying to figure out why is this thing different from what is given in that reference that I showed you. It's supposed to be 2.578, uh, and it's not. I eventually decided to do something that is, you know, out of whack. I had no idea why I even tried it. So what I did instead is I went to this properties that I imported. Instead of doing it by zone, I did it by plies. So I changed that to plies, and now I'm go and select your plies. This was uh, the A ply group, right? So right there, it was this one. Remember, there was ply group 1, which was for zone A, ply group 2, which was for zone AB, and ply group 3, which was for zone B. So instead of doing it by zone A, that we got that number, that answer, I tried ply group 1. In other words, by the plies in that group. And then again, obviously non-symmetrical. So, okay, let's go and do it for the second one. Instead of doing it by zone, we do it by ply group, and then go select ply group 2. This is the transition zone. Before we did it by zone, and that was zone AB. We picked zone AB. Say OK. And finally, the last material that we imported, double click on it, do it by ply group, and that's going to be group 3, which was for zone B. And then ran it. And now I look at the deformation. 2.58. Terrible. Because something that should have worked, something that should have worked, doing it by zone, it gave me the option, didn't give me the correct answer. Now I have confidence that if I do it by plies, I will get an answer that can be compared against something else. But if I do it by zone, I'm not I'm not getting the right answer. So this brings up an issue. Video segment 7, where I introduced the concept of zone, I solved that problem with ply group by zones. Sorry, not ply group. Import the properties by zones. And there were 2 zones there, okay? And I did it, got an answer, was perfectly happy with it because I had nothing to compare it to. That answer that I got there, I have no confidence. This is video 7 that I'm talking about. So right now, I'm going to do a correction after I finish this as a separate video. I'm going to a correction to video segment 7, show you the answer that you get there for the deflection is going to be different from what we got in video 7. Okay, the fix is easy, means we are not sure whether if you do it by zone it's going to work or not, because you can see that the numbers are different here. Okay, so we're going to do it by plies. All right, I'm sorry about this, but that is life. And this is very unfortunate because some mention, some discussion about this should have appeared somewhere, but after all, this is why, because there is no online or internet documentation or benchmarks, we are doing these series of video segments. Okay, good luck.